Algebra 1, Chapter 3, Section 2, Solving Linear Equations by Graphing. So, linear equations, we've talked about how they are straight line equations. Like if you look at them visually, they make a straight line. The simplest form of this is the function of x equals x. You also might see it as y equals x as well. It's the most basic form of this family of functions. And we call it family because every other linear graph is some version of this. You know, we do something to change its angle, and we do something to make it slide up and down or left and right. So everything is based around this one graph. So that's pretty much all it is about the family of graphs. What we really care about today are things called roots. So whenever you make a graph, unless it's a horizontal line, right? Like if it's a y equals 4 or something like that, it's horizontal. But whenever you have any other graph, at some point, it's going to cross the x-axis. And that is what we call a root. All right? So the whole idea is we want to take what could be a normal equation like 2x minus 8, and they usually don't start out like that. Sometimes they do, but usually it's like 2x plus 2 equals 10. And what we have to do is we have to get one side of the equation equal to 0. So we subtract 10 from both sides, and we get 2x minus 8 equals 0. And what we do is we change that 0 out for a y. 2x minus 8 equals y. Because now all of a sudden, that looks like some of the equations that we might be used to graphing. And what we're going to try to find is where does that cross the x-axis? And that is going to be what we care about. It's called the root, and it's actually the solution to this equation. So the root is the solution to this equation. All right. So let's go ahead and do that. And this is where the graphing calculator comes in really handy. You can do these by hand, and we'll do some by hand, but they're also really nice and easy and quick to put into GeoGebra, which will make it much easier to solve. So let's solve this equation here. So what I'm going to do is I'm going to substitute that 0 with a y, 1/3 x minus 2, and I'm going to graph it. And let's get my axes in here. And we'll do this line in red. That way, on the next one, we can also do it in red, or in a different color, and we can just use the same axis. Now, for this, I might not have much option. I might only be able to do table of values. And let's just do -6, -3, 0, 3, and 6. -1/3 times 6 is -2, minus 2 is -4. -3 times 1/3 is -1, minus 2 is -1 minus 2 is -3. -2, plug in 3 there, we get, sorry, it looks like a B in that picture, it's kind of bugging me, it's a 3. 3 times 1/3 is 1, minus 2 is -1, and 6 times 1/3 is 2, minus 2 is 0. And there we can actually see the root even. Let's plot those points down. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. -3. -3. 0. -2. 3 is -1. And 6 is 0. So when I draw this line out here, I can see it has a point where it crosses the x-axis. It crosses at the point 6, 0. So the solution to this equation is x equals 6. All right, let's do another one of those. We'll do this one in green. Make my green marker a little bit bigger here. Had it thin for something else. So same kind of thing. I need this 3x plus 1 equals 2. I need to set it equal to 0. So I'm going to subtract 2 from both sides. And I get 3x plus 1 equals 0. Now it's solved for 0. Substitute y in for that 0. So I get the equation y equals 3x plus 1. And same kind of thing. I'll make a quick little table of values over here. Negative 2, negative 1, 0, 1, and 2. Negative 2 times 3 is negative 6, plus 1 is negative 5. Negative 3 plus 1 is negative 2, 1. And then we've got 3 plus 1 is 4. 6 plus 1 is 7. All right, so let's see what those points can plot here. Negative 2, negative 5. Negative 1, negative 2. 0, 1. And 1, 4. And 2, 7. That's 4, 5, 6, 7. All right, draw my line. And run it through. I don't really like the way that is. I'm going to try to just move it just a smidge down. There we go. That's a little bit better lineup. So the root, that's the root there. I can't read exactly what it is. To me, it looks like maybe it's a little bit less than a half, so maybe it's a third. Negative 1/3 comma 0. That might be what it is. One way I can check is plug that into the original equation. 3 times negative 1/3 plus 1 equals 2. 3 times negative 1/3 is negative 1. Plus 1 does not equal 2. It equals 0. So that's not right. What did I do wrong here? Oh, do you want to see what I did wrong here? I'll highlight it in red. What is 1 minus 2? It's supposed to be negative 1. So my whole table of values is wrong there. This should be minus 1. So this equation should be 3x minus 1. So that changes my whole table. Let me just go ahead and get rid of all these orange spots here. Or all the green spots. Where was it? It was right. 0 is negative 2. There we go. All right, now it's back to normal. Let's try it again. Let's plug all those numbers in. Negative 2 times 3 is negative 6. Minus 1 is negative 7. Minus 4. Minus 1. Positive 2. And positive 5. So now I can plot those points in there in green. Negative 2, negative 7, so that's 3. That's 6, that's negative 7. Negative 1 goes to negative 4. 0 goes to negative 1. 1 goes to 2. And 2 goes to 5. So there we go. Now we've got our axes, or our graph here, done properly with the correct equation. Again, I made the little mistake of making it a little bit too high. That's pretty easy to fix for me. All right. Now, that looks like the actual root there. And this time my bet is the root is 1/3. Let's try that now. What is 1/3 of x? Sorry, 1/3 of 3 plus 1. Well, it's 1 plus 1 is 2. That checks out. Now you can see here, if you're quick with graphing, it works well. If you make a mistake on the graph, of course, it will give you the wrong answer, just like it did for a moment. But that's what happens with any equation, right? All it took was me checking my root, what I expected to get, plugging it in, and seeing that it didn't quite match up, so I knew something was off on the graph. So that's how you graph it by hand. I don't want to do it on GeoGebra yet, but I will show you these on GeoGebra as well.